So the video you're about to watch is poorly produced, to say the least, but I think that the content is important enough to where I can just bite the bullet and be a little bit embarrassed at the quality. I'm not trying to prove that you should buy the Mini-ITX PSU as a means of getting a lot of graphics power inside the S4. It's not the point. The point is to show that DC-DC power supplies, such as the Pico power supply or the HD Plex, you can run a lot more wattage in through them than they're advertised for. So if you're a modder and you're trying to cram as much graphics horsepower inside the S4 as possible, I'm hoping this will give you some ideas, and maybe you can find a power brick that will be good to go and you can plug right in the back. Or if you want to put a lot of power inside the box, this is one way to do it. Again, it's not finished and I don't think I get everything quite perfectly accurate in it, but I have tested it. This is not the only time I've tested it, and I hope that it gives you some ideas of your own. I developed the S4 Mini because I love to take my PC everywhere that I go, and one of my favorite places to go is in front of my TV on the couch. Today I'm going to show you how to modify your 160 watt Pico PSU to power this 250 watt Mini-ITX graphics card. So right now in my S4 over here, I have a GTX 750 Ti. It's a fantastic little card, plays all the games that I like to play at 1080p, it runs cool, quiet, and doesn't even require a power connector. Really, really nice for using these Pico power supplies. But a lot of my customers have actually sent me emails asking me if I could put anything more heavy duty in these boxes. So today, we're not just going to demonstrate how you can get a 260X running in there, because the Pico already supports that with a normal power brick, but we are going to demonstrate how you can rig up a Sapphire 285 ITX inside of an S4 chassis. So let's get started. So my partner Dean and I have already run through and put all these cards to their paces in order to determine the maximum wattage this system is going to draw. I'm using the 4790S i7, and for the three cards we chose, the 750 Ti, which doesn't draw anything, it's amazing, the 260X from Sapphire, and this goes in all of my S3 systems I've built the last couple years. Fantastic card. And then finally, of course, we had to benchmark what we're trying to aim for, the 285 ITX. And we played a bunch of different games, put the voltage meter on there, and Alien Isolation, Civ 5, Skyrim, a ton of games. But we also stressed it out the most we could, running Prime 95 and Heaven at the same time, and the max the system ever drew was 260 watts. So we need to find a power supply that's going to handle 260 watts. We need to know that our Pico power supply can handle that because it's rated for like 160, and we need to figure out if our wires are going to melt and burn everything down. So we're going to get started. So I use the Mini-Box brand of the Pico power supplies. I think they're fantastic, and you can push quite a bit of juice through these things. You do need to change the wires. We're using a completely stock Pico. This is a 160 XT model that's inside my chassis right now. I have my SSD plugged in, and I have my 4-pin Molex. So what we're going to do is we're going to need to get an 8-pin connector and adapt it to a 4-pin Molex. So I'm going to actually use a 6-pin connector to a 4-pin Molex, like you find in basically every single video card box that you can buy. And here's what I've done. Here I have my 6-pin Molex connector, and I have my 4-pin Molex connector. Now if you're looking at this connector, how I have it oriented in the shot with this little bar right here, the pinouts are 1, 2, 3, and 4 in that order. And you want to connect the top 3 pins from your 6-pin Molex connector, the voltage minus, to the middle 2 of the 4-pin Molex connector. And to do that, because you're going to need to split it off from there to an additional 2-pin connector, like so. Next, you're going to use your adapter for the video card, and you're going to plug it into the 4-pin Molex connector that branches to your SATA on your Pico. Now this is going to draw quite a bit of energy, and these wires are just not up to the task, and they're going to get hot, but for our testing purposes it's going to work fine. And lastly, I'm going to take my mod connector and I'm going to plug it into the 8-pin on my GPU. And at this point, it's all ready to turn on and see if it works, but we have to make the power supply first. So Dee and I have actually purchased quite a few of these little power supplies. There's a bunch of different brands. You can get them on Amazon, and all of them have been junk except for the one by Meanwell. It costs about $50, but it's UL certified. You can actually look that up on the UL website. It's not just printed on a fake label from China. And we've already tested it, and it works great. So what we did to wire it up is we took a standard power cable. This one was easier for us because it was already flat. And we separated the ground from the neutral and the load. And we just wired it to the ground, the neutral, and the load on the power supply. This particular power supply is a variable input. It goes from 11 to 14 volts, I believe. Is that right, Dean?
Yep.
And its max load is about 350 watts. In our testing, we found that we couldn't just take one voltage positive, one voltage plus, one voltage minus, and plug it into our 4-pin adapter, because the power supply actually splits the max power over all these terminals. So what we did here is we just crimped all these little wires together and drew them all into this 4-pin connector. I just chopped this off an old power supply that wasn't working anymore. And it's really simple to hook up. Right on the power supply, you see the voltage plus, the voltage minus. Just make sure the yellow ones are on the plus and the black ones are on the minus. And that you can follow the pinouts if you've already chopped one off the motherboard. And then from there, we can actually plug it into our Pico PSU connector. And we can turn this sucker on and see if she runs. So we're not physicists or electricians or liable for absolutely anything that you do to your house or your computer. But we do have some official glasses.
The Mini-ITX 350 12-volt power supply going through our harness into a 4-pin Molex connector into our Pico. What you'll have to account for is line loss between the Meanwell and the Pico. So first you'll want to measure the voltage coming off the Meanwell. You'll just need a multimeter set to voltage and make sure it's in DC mode. Then you'll take your probes, you'll put a ground on one set of the voltage minus and another probe on the voltage plus. We see here we're getting 12.02 out of the Meanwell, which is what we would like. But we need to make sure that voltage is sufficiently getting to the Pico. So you'll carefully do the same over here on these two wires into the Pico. So you'll take one of your probes and set it on one of these solder points and stick another probe on the other of the two, and you'll hold it until you get a steady reading. We're getting 11.92. So we'd like to make some adjustments so that this is within a few hundredths of percent of 12 volts. And so for that task, it'd be good to have a friend or some alligator clips to hold these on here. Once your friend has a steady reading into the multimeter, we get 11.92. Take a smallish Phillips head, and there's an adjustment right next to this LED. And you just put it in and slowly turn it, as it's a fairly sensitive potentiometer here. So we can get it up to about 12, a little under is fine. We'll call that good.
12 volts is pretty good.
So now that we know the Pico is getting a solid 12 volts in, we can start benchmarking the system.
And see if it holds. Do you think it's going to drop?
There may be a drop while you're benchmarking the system. The Meanwell doesn't dynamically adjust this for you, unlike a normal power supply. So you want to make sure that your standard operating voltage is within bounds, but also high enough that at load you're not dropping too low, and then your system will just shut off.
But that could actually kind of be a positive, right? Like for some overclocking scenarios.
Yeah, so if you're a talented overclocker, you could use this adjustment to get a little more voltage into your board, which might aid in getting higher clock speeds.
So right now our temperature is at 39. Our wattage from our What's Up Pro is at 47.8 idle. And I'm going to load up Prime 95. I gotta type and hold the camera.
Maybe I should.
Oh, it's fine. And I'm gonna hit the blend test. Starting. Bam. There it goes. Temperature is gonna be shooting up. And our wattage is at 113.1.
This might be a good time to check the voltage one more time to see if that effect of a voltage drop comes into play before you start your full battery of tests. We're under 12 now at 11.85, which should be fine, but you can adjust it again here if you'd like to keep it up near 12. Be careful though, because when your load drops off, you'll suddenly get a higher voltage into the Pico.
Okay, second test. We are going to keep Prime 95 up, and we are going to launch Heaven. Boom. The frame rate isn't the greatest because we're running high settings, and Prime 95 is taking up most of the system resources. But again, we just want to stress the system to its max. And we see here that our wattage is at 273. Ooh, 274. This is higher than the last time that I tested this. Our temperature is climbing steadily. It's at 67, which is totally fine. The CPU will run at 90 Celsius all day long. But let's now check for a voltage drop.
Checking the voltage a third time. During the full battery of tests, we're getting 11.45 into the Pico. If your system's not stable, you probably will need to adjust your voltage up at this point, but if it's holding stable, there's no reason to do that.
Which it is. It is running beautifully. I mean, you cannot get a system more maxed out than Prime 95 plus a 3D benchmark like this. So I'd say that this system is good, but we want to run it for, I would run it for 6 hours plus to be completely dead solid. But while we're doing that, let's talk about the temperature and the gauge for the wires. So, not just having everything plugged in, we also need to make sure that our wires are the appropriate thickness. Otherwise, they'll melt and burn, and then we'll have problems. So, for going into the mean well, we have a lot of different lines, and that's running off 18 AWG. And that's fine. What's the temperature on that?
These are at about 30 Celsius.
Which is almost room temperature right now. It's really hot in this room. And then going into our, that's what I'm more concerned about. That looks like 24 gauge to me. And that's where I'd worry because the video card's feeding off of that.
And this is about 36 at the hottest, and it will heat up as it runs.
Yeah.
So that's why I want to keep an eye on it so insulation doesn't start melting.
Yeah, we need to check that over time. And what about our makeshift adapter for the 8-pin for the GPU?
This one?
Yeah.
These are warmer at 40 Celsius.
So it's interesting that even over there, they get hotter than feeding through off the Pico. Can you read it to Pico again one more time?
Yep. The ones we'll need to watch the most are these, which are carrying the full load, and they're fairly small. Look, these are really hot at
those are like 24.
Nearly 70.
70 Celsius. So this is the weak point in our system right here. So when we rewire this system, we don't want to do a double bunny-eared loop like this. We want to use at least 15 gauge to carry the amperage, which is what, 23 amps or something like that, all the way through to our Pico. Alright, so this brick right here is pretty big for a power supply. It's like the size of an Xbox One power. Okay, it's not that big. But I've had customers actually want to use 2 power bricks to do their system, 2 like these 19 volters. And these ones over here that I use for the S3 minis, you know, they're sizable, but they've been saying that it'd be a fine solution if they use 2, one for the video card and one for the CPU. So combining them both into a brick like this is, I prefer this solution. And you can pretty it up, paint it, cover up the wires. And what I'm going to do is I'm actually going to buy 2. I'm going to put one on my desk somewhere over here, and then one below my TV, so I don't have to carry that around when I bring my S4. I can just pick up the S4 and plug it into the wall.